Let's look at part B of question 5 now. This is the CSEC Mathematics 2020 January paper. It says, use the cumulative frequency curve on page 18, that's the previous curve, to complete the frequency table below. I've copied the curve here. Okay, so this is a cumulative frequency curve. We're going to complete the table below. Okay, now it says m, when m is greater than 0 and less than or equal to 2, that means when the mass m is between 0 and 2, you have a frequency of 20. Let's see, 0 to 2, right, of 20. The cumulative frequency is 20. You can see it here, right? From 0 to 2, you go straight up to the curve, then you go across, and you see that it's 20. Okay. Now, 2 to 4. M greater than 2 and less than or equal to 4. What is it? Let's see. You have M between 2 and 4. So between 2 and 4, what you find? What do they ask for? They ask for frequency, not cumulative frequency. They're asking for frequency. Okay, and you can see it here, that if it was cumulative frequency, it would keep adding up, but it's just frequency they want. Good. Oh, they have M between 6 and 8. Let's look at that. And they have it as 6. Between 6 and 8, let me erase this. Alright, okay, so between 6 and 8, they have that number as 6. So if you go from 6 up to the curve, and from 8 up to the curve, you have a difference. The difference lies somewhere from about here up. So that's 90. 2, 4. Okay, so each small squares represent 2. Because here you have 90, 92, 94, 96, 98, 100. So if you go from close to 100 coming down to for about 6. So what they're saying is that this difference here, this little difference here, the difference between here and here, this height is about 6. That's what they mean. Okay? And let's look at what else they have. 8 to 10, between 8 and 10, that's 1. So, between 8 and 10. Okay, you can see that because if you go from 8 up to the curve, and then from 10 up to the curve, the height of this line is here, and the height of this line is a bit more, and that difference in height is about 1, as they have here 1. So let's see what we're going to do with this now. Let's erase what we did here, and then here now 2 to 4, between 2 and 4. Let's do the same thing between 2 and 4. M from 2 to 4. So between 2 and 4 would represent this area. Let's project up from 2 to the curve, then project from 4 up to the curve. Now let's go across. It seems as if it's 20. Let's go across from here. Let's look like 68. It looks like 68. So 68 minus 20. 68, 58, 48. So you're looking at about 48 for that. All right. You're looking at around 48. So this number here would be 48. What about between 4 and 6? M greater than 4 and less than or equal to 6. Between 4 and 6. Let's get rid of these and try out 4 to 6 region. Let's go to 4 and project. We go to 4 and the project up to the curve. Touches it about there. Let's go to 6 and project up to the curve to touch the curve. Let's go across now from 4. It looks like about 68 or something from 6 to the curve and then going across like 94. Could be. So the difference in height here from here to here is about 94 minus 68. 94 minus 68, right? So 8, 9, 10, 11, 12, 13. This would be 6, 8 minus 6, 2. Looks like around 26. Okay. So we'd have 26 as that number that should come here. So between 4 and 6, it looks like about 26. So let's write that down. 26. Okay. Good. The next thing here under part B, they say a student you chose not random. Find the probability that the student estimated the mass to be greater than 6 grams. The student estimated the mass to be greater than 6 grams. So what you're really finding out is the probability that the student estimated the mass to be greater than 6 grams. To be greater than 6 grams. Now, remember the definition of probability as it would apply here. It would be the number of students who estimated the mass to be greater than 6 grams divided by the total number of students. The probability that a student we choose at random estimated the mass to be greater than 6 grams. So, what was the total number of students? Yes. So what it's saying up here, just to take back a look at it, 100. So you have 100 students, and that 100 also coincides with the number, the maximum number in the cumulative frequency table. So what we have here is the total number of students is 100. Now, how many students estimated the mass to be greater than 6 grams? Let's look at the curve. Let's just erase what we have here and go through this part of the question. All right. Now, 6 grams. Now, the total number of students who estimated that exactly 6 grams would be from the 6 coming up to the curve. Good. And then going across. All right. So, it would be about 94 exactly. If you consider, no, what I'm saying, if you draw the line from the 6 going up to the curve and then go across, the number you get is about 94. Right, that's what I'm trying to say here. So we want to find out the number of students who estimated the mass to be greater than 6 grams. Now, greater than 6 grams would be from this line going this way, greater than 6 grams. All right, could be 7, 8, 9, 10, 11, whatever. Well, up to 10. That's where it stops. Whatever number of grams is greater than 6. Now, the fact that you have these arrows pointing to the right, it means that you're looking from about 94 up, the number of students who estimated the mass to be greater than 6 grams. All right. Now, the number of students who estimated the mass to be greater than 6 grams. You're looking at more than 94. But how many exactly is it? What we're looking at is how many students estimated the mass to be exactly 6, 7, 8, 9, 10, whatever number that we're going to be looking at. Let me just erase these arrows. Don't really need them again for the rest of the question. Now, here, some students estimated the mass to be 7, some 8, some 9, but it goes up to 10. So 10 is the maximum. We go from 10 to the curve, then project across. We had no more than 100. That's why you didn't pass this level. Now, what you can say is that this region here represents the number of students who estimated the mass to be from between 6 and 10 grams. Now, this number right here seems to be about 94, as I said before, and this number is 100. You see that? So this represents 100 and this represents 94. Right here is 100, right here is 94. So if we say 100 minus 94, we get 6. So what it's saying is that a number of students who estimated the mass to be greater than 6 grams would be 6 students. All right. So what you need to write here is 6 over 100. And of course, 600 is the same as 6%. You can divide this down if you want a fraction to 3/58. 3/58 it should be. Three over 50 if you want it as a fraction. 600 is a fraction, but it can be simplified to 3/58. Remember, you can write the probability as a decimal, fraction, or in percentage. So in this case, it is 6%, which is the same as 0.06, which is the same as 3/58, whichever way you want to write it. So let's see what else is happening in this question. Oh, the question is finished. It says total 9 marks. All right. All right. Let's just go back to this for a little while. Suppose they had said how many students estimated between 4 and 6 grams. What's the probability of a student who estimated the mass to be between 4 and 6 grams. What you would have to do is this, and then this, and the 6 grams. That's what I already marked. So what you would have to say is that this looks like about 70, and this, yeah, 94. So you'd say 94 minus 70, that's about 14, that's 14. So it would be 14% if they had said the probability that of a student who estimated the mass between 4 and 6 grams, right? That's what would have happened. Suppose they had said, what's the probability of choosing a student who estimated the mass to be less than 3 grams? What you'd have to do is point to 3, project up to the curve, then from the curve you project to the left. This looks like around 44, right? So you have 44 here, so it's 44 over 100, 44%. All right, so I will see you in the next question.